This video is going to talk about just factoring using a generic rectangle. So we're just going to look at a couple of quick examples to get you just more thinking about it, and then you can try a couple on your own. Okay, so remember the goal with factoring is so that we could perhaps find the intercepts. So if we wanted to know when this equaled 0, if we factored, we could see that pretty quickly. Now you're going to learn some interesting strategies in the upcoming sections that will help you do this in a different way and in a less concrete way, but the factoring is a good thing to know how to do because the quicker you are with it, the easier it'll be. So here's some tricks with factoring. When you're factoring, you definitely want to look at the leading and the final term. Okay? So since it's x to the third, that means that there could potentially be 3 factors with an x. Okay? It also means that maybe it's just x squared times something with an x. But that's what we're looking for. We're looking for that potential 1x term. Okay? The second thing, the reason we look at the 6 is because the 6 will tell us what some of the potential terms at the back end will be. So the only way to get the 6 is to multiply all these constants that will be at the back end of these. So we think about the ways to multiply to 6. 2 times 3, 1 times 6. Negative 2 times negative 3. So those are all giving us ideas of potential factors that we're going to try. So we're going to give it a shot and we're going to try a potential factor because of the type of problem that it is. Okay, so let's take a look at making a guess and going with it. Okay, so we make a guess that perhaps, let's say, maybe it'll be x plus 2 as a factor because I know 2 goes into 6. So I'm going to try that and I'm going to put in my highest power, x to the third, because it has to appear with the x term. So that means that this has to be x squared, and that means that this has to be 2x squared. It has to be. But I take a look and I see negative 4x squared. So I got to figure out, okay, I want this to be negative 4x squared, but I have 2 x's. That means this has to be negative 6x squared. It's the only way to get 2x squared. So now, because of that, I have to fill in this outside piece. This outside piece down at the bottom has to be negative 6x because that's the only way to get negative 6x squared in that spot. The next thing I do is, well, because this is here, I'm going to know for sure that this corner is going to be negative 12x. So that has to be negative 12x. So there's no way around it. Once again, though, I don't want negative 12x. I want just one positive x. And the only way to get one positive x, so I kind of keep that in the back of my mind, negative 12x plus 13x. So 13x has to go there in order to get x plus 2 to work. So x plus 2, 13x has to be there, so that means that this corner down here has to be 13, because 13 times x will give me 13x. But then that leaves this corner with positive 26. Well, shoot, I don't want positive 26. I only want 6. This tells me when everything's said and done that x plus 2 is not a factor of my polynomial. So I am done. It is not right, and I'm going to start over. I'm going to start over, and I'm just going to change one little thing. I'm going to change this to negative 2. We're going to see if negative 2 works, because all I got to do then is erase these pieces and change this to negative. The goal remains the same. If this is negative 2x squared right here, and I want negative 4x like I noted here, then this would have to be another negative 2x squared. Then I accomplished my goal of getting negative 4x squared. Now, once again, that means I can fill in the outside, so this has to be a negative 2x. And that also influences the top. So this up here will be positive 4x. Okay, so that positive 4x is not exactly what I want. I want a single x. Remember, that came from the original problem. So that means this has to be a negative 3x, because negative 3x plus 4x equals x. So these 3 all add up to the proper value. Now I want to fill in the bottom. It has to be negative 3. And take a look, the top will be 6, and that is exactly what I want. So that means that x minus 2, this factor, times this factor, give me this polynomial. So I've successfully started my factoring. This can be factored into x minus 2 times x squared minus 2x minus 3. So I factored it into one single monomial, but I want to see if this is more factorable. And this one might be a little bit simpler for us to see. It's a simple x squared term, negative 3. There's only one way to get negative 3, and x squared. And that means x and x has to be here. And remember, these two have to add up to negative 2. So that means this will be negative 3x, positive 1x. This is the diamond problem one. Whenever you have a quadratic, you can use the fact that this product, negative 3x squared, has to be the same as this product. And we also knew that we wanted it to add to negative 2x. So that's negative 3x and positive 1x. So that helps me fill in my outside, plus 1, minus 3. So I can factor this even further. Yes, the x minus 2 is still there, but the second factor can be factored into x minus 3 times x plus 1. So there's one example. I'll give you one more example, and then you can try some on your own. In this example, this one's a little bit different. So once again, our goal is to factor this. First of all, before I get started, I see some common factors. So I see that they all have a 3 as a coefficient that can be factored out. And I also see that they all have an x. So my first step is to factor out the 3x. Because 3x times x squared gives me 3x to the third. 3x times negative 6x times negative 2x gives me negative 6x squared. And then 3x times negative 8 gives me 24x. So a common factor is a really important piece. Because remember, if this was a polynomial and I was trying to graph it, this would tell me one of the zeros is when x is 0. If x is 0, the whole polynomial will be 0. And that should make sense even from the original. You should see that if x is 0, that will be a 0, a root intercept in your function. So now we want to factor the second piece a little bit further. So we want to look at what this can be factored into. This can get really quick when it's quadratic because you've got more practice. You also know that the box can only be 4 squares big. You know that the x squared and the negative 8 have nothing in common. These two corners need to add to negative 2, but they also need to multiply to negative 8x squared. They have to add to negative 2 because of my polynomial. They need to multiply to negative 8x squared because of a trick I learned in Algebra 1. So this has to be negative 4 and positive 2. And I can check it by filling in the rest of the outside, negative 4, positive 2. And I see that that gives me the negative 8 that I want. It gives me the 2x, the negative 4x that add to negative 2x. So I factor this fully into x minus 4 times x plus 2. And of course I have my original factor of 3x out in front. This is the fully factored form of the original polynomial. Here's a couple of problems to try on your own. See if you can get them. I'll post the solutions. You can pause the video and see if you got them right. So here's 2 examples to try on your own. Pause the video now. Give these a shot. I know these numbers look big. By the way, this is a 14. So like 23, 11, it seems a little daunting. But remember, focus on the goal. You look at this last term, and you know there's only a couple ways to get 14, and that's 7 times 2, or 1 times 14. Or maybe they're both negative. Negative 1 times negative 14. So there's only so many ways that you can do that. So you try some things and you see what happens. You also notice the 2 on the front one. So just like we talked in the beginning, that means that one of my factors is probably 2x and something. And the rest are x's. That's the only way to get 2x at the front. So give that a shot. And letter A, make sure you find that common factor first. But pause the video here. Try it all on your own, and then look at the answers. If you look at the answers ahead of time, you won't get that same learning experience. So pause the video, try it on your own. So here are the solutions. Hopefully you pause them and try them on your own. Of course, this one is fully factored. This is just the intermediate step that you should have found right away. And this one you just had to try some things. Hopefully you tried something like x plus 2 right away, or x plus 7, or x minus 7. The 2x minus 1 is a little bit harder to get right away. So focus on the simple x terms and worry about the 2 a little bit later. Like I said, though, we're going to be learning some strategies to help you do this stuff a little bit swifter, but it's a lot less concrete and more likely to be forgotten. So give it your best shot. Bring in questions. Ask for more help if you need.